Guys, so welcome again to my YouTube channel, Mathematics Medicine. So in today's video, we are going to look more into the examples of a group. So if you are new to this channel, please don't forget to subscribe, like, comment, and share. So in my previous video, I've talked about an algebraic structure, the definition of a group, and the properties that a group must satisfy, and I'll give some examples of a group. Now, in today's video, we are going to look more on examples of a group. That is, now, the first example we'll be looking into is the sets of rational numbers under the operation addition. So that is rational numbers under the operation addition. Is it a group? Let's check. Now, we know that a rational number is a number that can be expressed in form of fraction. That is A over B. So where B cannot be equal to 0. Okay? And don't forget, the set of integers can also be found in what? In set of rational numbers. So now, if you take any element in the set of rational numbers, the associative property will hold. That is, if you take any element in the set of rational numbers, let's say we take 1 over 2 and I take 3 over 4. Okay, so we add these two elements together. So we are going to have 1 over 2 plus 3 over 4. So the LCM is 4. So we are going to have 2 plus 3, which is equal to 5 over 4. And 5 over 4 is what? Is an element of the set of what? Rational numbers. So that shows that the closure property holds. That is, if you take two elements in set of rational numbers, if you add together, the answer will be what? Will be a member of what? A set of rational numbers. So the closure property is satisfied. Now, what about the associative property? So the associative property, that is, we have A plus B plus C. So this must be equal to A plus B, then plus C. Now let's take three elements from the set of rational numbers. Let's say we have 1 over 2 plus 3 over 4 plus 5 over 4. So will this be equal to 1 over 2 plus 3 over 4, then plus 5 over 4? Let's check. Now this will be 1 over 2 plus, the LCM will be 4. Then we have 3 plus 5, okay? So which is equal to, the LCM will also be 4. We have 4, then that will be 2 plus 3, then plus what? 5 over 4. So the LCM will be 4. So we are going to have 2 plus 3 plus 5 is equal to, and the LCM will also be 4. 2 plus 3 plus 5. You can see 2 plus 3 plus 5 will give us 10. So we have 10 over 4. 10 over 4 equals, and you can also see 2 plus 3 plus 5. So we have what? 10 over 4. Okay, so 10 over 4 is what? Is 5 over 2, 5 over 2. So we can see, and 5 over 2 is a what? It is a set of what? Rational numbers. That shows that the associative property holds, and we can see that it's equal. It's equal. So the associative property holds. So the next one will be the identity element. So what will be the identity element? What are you going to add together in the set of rational numbers that will give you that same integers or that same number? Let's check. Let's clean this part. Yeah, now let's check. Let's find the identity element. That is A over B, then plus something. So let's say that something is E. That's the identity that we need, that will give us A over B. So if you subtract A over B from both sides, so we have E, which is the identity, is equal to A over B minus A over B, and that will give us 0. So that shows that the identity element here is what? Is 0. Okay, it's 0. That is, if you take any two integers, any two rational numbers from Q and you add together, if you take a rational number with 0, you must get that rational number. Okay, that is 1 over 2 plus 0. This will give us 1 over 2. 3 over 2 plus 0. This will give us 3 over 2. 5 over 2 plus 0. This will give us 5 over 2. 3 plus 3 over 3 plus 0. This will give us 3 over 3, which is 1. So if you take any two numbers, any numbers in the set of rational numbers and you add 0 to it, it's going to give us that same number. So the identity element is 0. So the next property is the existence of the inverse. That is, for each A in G, there exists B in G, such that A plus B must be equal to B plus A must be equal to, that is, A plus B must be equal to 0, since the identity element is what? Is 0. Okay, so then if you subtract B from both sides, you are going to have A is equal to minus B. So if you take any element, the inverse will be what? That the negative of that what? Of that element. So where B is equal to a we want to find B rather, sorry, so you're going to have B is equal to minus C. So where the inverse of A will be what? Negative A. Now if you take 1 over 2, what will be the inverse of 1 over 2? The inverse of 1 over 2 will be minus 1 over 2, because 1 over 2 plus minus 1 over 2 will give us 0, and 0 is the identity element. So we can see that Q comma plus is a what? Is a group. But is it an abelian group? Let's check for the properties of an abelian group. Now, for it to be an abelian group, we said A plus B must be equal to B plus A. Okay, so if A plus B is equal to B plus A, then Q comma plus is an abelian group. Now, let's take any two elements. Let's say we have A over B plus C over D. Will it be equal to C over D plus A over B? Let's check. So the LCM here will be BD. So we have BD, then that will be AD, then plus BC. And then the LCM here is also what? DB, which is also BD. Then we are going to have what? BC, then plus what? AD. So they are equal. They are equal. Then Q comma plus is an abelian group. So where A comma comma B comma C comma D are set of what? Q. And then B comma D are not equal to 0. So therefore Q comma plus is an abelian group. Thanks guys for watching. See you next time.